Hello, science students. Welcome to today's lesson about Newton's second law of motion. If you recall from our last lesson, we learned Newton's first law of motion. It's referred to as the law of inertia. And that law states that an object at rest will remain at rest, and an object in motion will remain in motion with a constant speed unless acted upon by an unbalanced force. Some key terms to make sure that you have defined and in your notebook are force, motion, and inertia. If you haven't already recorded those, you might want to make sure that you have them in your notebook, as well as Newton's first law. To review, Newton's first law of motion says that something that's stationary has to have a force act on it to cause it to move. In this example, you can see a soccer ball that is at rest. It is sitting at rest and not moving. The ball will not begin moving until a force acts on it, like a foot that strikes the ball. That ball is going to remain in motion along its trajectory in a straight line unless a force acts on it, such as that net at the back of the soccer goal. As that ball comes in contact with the net exerts a force on the ball, and that stops the ball's motion. Today, though, we're going to focus on Newton's second law of motion. His second law of motion is actually a mathematical equation, and it's how he was able to identify and describe exactly how mass and acceleration can change the force, or how force, mass, and acceleration are all related to each other. Newton's second law of motion states that the net force of an object is equal to the product, which means multiplication, of its mass and acceleration. Or you could write it as our formula, F equals ma. F stands for force, m stands for mass, and a stands for acceleration. So the mathematical formula F equals ma means you take a value for force, it's equal to the mass times the acceleration. This diagram would be very, very helpful to have in your notebook. This circle diagram can help you figure out how to find any one of these values. If you know two of these values, you can find the third value. Make sure that you copy this into your notebook. Let's walk through some examples. If you want to find force, if you're trying to identify the force of an object, cover up the letter F on this diagram. You can do that with your thumb, or if you draw the diagram, you can shade it in. But when you cover up that symbol you are after, you're left with the formula to calculate the other item. So in this instance, we want to find force. That leaves us with ma, m times a, or mass times acceleration. If you were trying to find out the mass of an object that is traveling at an acceleration and a certain force, you can use this same diagram to come up with that. You cover up the letter m, and you're left with the formula F on top of or over a. That is set up like a fraction, and that means to divide. So you end up with force divided by the acceleration, and that will give you the mass of the object. Or if you're trying to calculate the acceleration of an object, how fast its speed is changing, you will need to cover up the letter a. That's going to leave you with the formula F over m, or F divided by m, force divided by mass. Let's walk through some practice problems. How fast is a 20 kilogram bicycle accelerating if a force of 100 newtons is applied to it? Find the formula by covering up the letter you want to find. We're trying to find acceleration in this one, so you'd cover up the a and be left with a equals F divided by m. Now you substitute those values. Force is 100, mass is 20, so your formula would be acceleration is equal to 100 newtons divided by 20 kilograms. Then the last thing you would do would be actually calculate that answer by doing the math, and you'd come up with 5 meters per second per second. So every second it's gaining another 5 meters. Let's take a look at another one. This one wants to know how much force is on the object if its mass is 5 kilograms and it is accelerating at 9.8 meters per second per second. So the first thing you do is you find your formula by covering up the letter you want. We're left with F equals ma. You want to substitute the values. We have a mass of 5 kilograms and acceleration of 9.8 meters per second, and we're up with 5 times 9.8, and your answer would be 49 newtons. Our third example wants to know the mass of a bowling ball. It's traveling at 12.8 meters per second and has a force of 48 newtons. Cover up the letter M and end up with the formula F divided by A. Substitute the values of 48 and 12 where they belong, and then do the math and come up with an answer of 4 kilograms. Hopefully these examples help you understand Newton's second law of motion and give you a chance to practice using Newton's second law of motion to find a few examples of either force, mass, or acceleration. Thank you for your attention, and I hope you have a wonderful day.